Hey, hi everyone. In this video, we are going to solve the Leetcode problem of the day, and the problem is lowest common ancestor of a deepest leaves. Well, the description of the problem is very confusing, so we are going to jump on the drawing pad, and first of all, we are going to understand what is this problem all about. Then we are going to understand what is the approach to solve this problem, and we are also going to understand what is the intuition behind solving this problem using that particular approach. And then we are going to code it using Python. In this problem, we are given a tree and we need to find what is the lowest common ancestor of the deepest leaves. So first of all, for a given tree, we need to find what is our deepest leaves. And for that, we need to find out what are the leaves. So we are going to understand it using 4 different examples so that the question is completely clear to us. What is a leaf? A leaf is any node in a tree which has no children. So right now you can see these are our leaves. These nodes has no children and that is why they are called as the leaves. Now what about the deepest leaves? Find out those leaves which are in the deepest level in our tree. So for that we can say the root node is at level 0. The children of the root nodes are going to be level 1 and their children are going to be level 2 and their children are going to be level 3. Now again let's go back to the fact that 6, 7, 4, 0 and 8. These are our leaves and the leaves are at level 2 and level 3, right? 6, 0 and 8 are at level 2, 7 and 4 are at level 3. So what's the deepest level? The deepest level is level 3 and that is why for this particular tree, the deepest leaves are 7 and 4. Okay. Now we need to find out the next thing. So now when we know that the deepest leaves are 7 and 4, what is the common ancestor for it? Now what is an ancestor? Ancestor is a parent, a grandparent, great grandparents. Just like a family tree, we have our parents, and their parents, all are our ancestors. We need to find the common ancestor. So the common ancestor for 7 and 4 are 2, 5 and 3, because for 7 and 4 we can see 2 is the parent and the parent of 2 is 5, the parent of 5 is 3. So we now know how to find the common ancestor, but we need to return the lowest common ancestor. So the lowest common ancestor is going to be 2 because 2 is at the lowest level, and for this tree we need to return who is the lowest common ancestor of all the deepest leaves we have. So for this example, these are our deepest leaves. 2 is the common ancestor, 5 is the common ancestor, and 3 is the common ancestor. 2 is the lowest, that is the lowest in the level. So 2 is going to be our answer. So we are going to return the node number 2 and this is going to be the answer. The output you will see for this example, which is example number 1 in the question, is going to be 2, 7, 4 because they are printing all the nodes which are there from the node number 2 or the node which you will return. Let us try to take another example to understand it more. Now let us try to find out what are the deepest leaves. So we know that this is the root node which is at level 0. The children of the root node is at level 1 and their children are at level 2. Now we know that these are our leaves and all of them have the same level, which is 2. So here all of these nodes are the deepest nodes. Now try to find out what are their common ancestors. Now you might think that 5 and 1 are the common ancestors, but they are not. And the reason is the leaves are 6, 2, 0 and 8. 6 and 2 have a common parent or a common ancestor, which is 5. But the other deepest leaves 0 and 8 have different parent, different ancestor, which is 1. So now we need to ask these nodes that what is your common ancestor or what is your common parent. So they both will say that my parent is 3. So here we can see that 3 is the node which is the parent of 5 and 5 and 1 are the parents of all our deep nodes. So the answer for this particular tree is going to be 3. And the reason for this is for all the deepest nodes, 3 is our common ancestor. 5 and 1 are the ancestors for 6 and 2 and 0 and 8, but they are not common for all the nodes, all the deepest nodes. But 3 is common, right? From 3 we can reach to 6, we can reach to 2, we can reach to 0 and we can reach to 8. But from 5 we can only reach to 6 and 2. From 1 we can only reach to 0 and 8. And we are not covering all our deepest nodes. So we need to find that parent from where we can just reach out to all our deepest nodes. Taking you back to the example number 1, if you will say that hey, 3 is my answer. So yes, 3 can be your answer because from 3 you can reach to 7, you can reach to 4, and 7 and 4 are our deepest nodes. But 5 is also an answer. From 5 you can reach to 7 and you can reach to 4. And 2 is also an answer because from 2 you can reach to 7 and 4. And who is the lowest here? The lowest is 2. So we can say 2 is our answer here. And for this example, we can say 3 is our answer. Let us take 2 more examples which are very important to understand. This is the first one. Now in this example, a lot of people are having confusion. This is the example number 3. So in this example, the given answer is 2, but people are confused that hey, the answer should be 1 or the answer should be 0. Now let me tell you why the answer is 2. First of all, what are our leaves here? 2 and 3. These two nodes are our leaves, right? Now what is the deepest leaves? See, this is the level 0, this is level 1 and this is level 2, right? So this is the deepest level in our tree, and for that 2 is going to be our deepest leaves. So let us ignore this 3. Now what about 2? How is 2 the answer and not 1 or not 0? Let's say you are saying that 0 is an answer. Well, 0 can be an answer because from 0 you can reach to 2, right? So 0 is one of the possible answer. And why are we reaching to 2? This is because 2 is our only deepest node here or only deepest leaf here. 1 can also be an answer because from 1 you can reach to 2, right? You can just go here and you can reach to 2. So 1 can also be an answer. Out of 0 and out of 1, 1 is the lowest here, right? See the question again. We need to find the lowest common ancestor and not the common ancestor, okay? So the lowest here will be 1. But think about this. 2 can also be an answer. And the reason for this is, let us consider this is our tree. So this tree is having all the deepest nodes, right? So this can also be an answer because 2 is also a part of its family tree. You can reach to 2 from 2, right? So 2 can also be an answer. So out of 1 and out of 2, 2 is at the lowest level, and that is why for this particular example, 2 is our answer. Now after understanding this, you might have a confusion that, hey, then why not 7 is an answer or 4 is an answer here? And the reason is 7 and 4 both are our deepest nodes. So if you will say 7 is my answer, then 4 will not be considered. You cannot reach to 4 from 7 because from 7 you cannot go down and try to reach 4, right? And from 4 also you cannot go down and try to reach 7. So then you will have to say, okay, then I will consider 2 as my answer because from 2 I can reach to 7, I can reach to 4. And that is what's happening here. 2 can alone be an answer, and 2 will say that I can cover all the deepest nodes or all the deepest leaves. There is one more scenario, a simple one, that is if we have just one node, that is the root node. So here again we will find what are the leaves here. So the leaves are just one is the leaf. And is this deepest? Yes, we have just one level, which is level 0, and this is the deepest here. So we can say this is our answer because this particular node is covering all the nodes which are deepest leaves here. So don't try to overcomplicate the question or overread the question. Just know that you need to find the leaves, then find the deepest leaves, then find their ancestors, and then find their common ancestor, and then find what is the lowest out of it. You know, it's like understanding the question one by one. So now let us try to understand how can we solve this particular problem. Well, whenever we have a question related to a tree, one of the most common way to solve this is using BFS or DFS, which is breadth first search or depth first search. For this example, DFS is the better solution, and I will tell you the reason. First of all, let us try to understand how can you solve this using BFS and why BFS is not the best, or I would say not the easiest way to code it. Now to solve this question using BFS, we need to process our given tree level by level, right? For that, let's process the root node which is at level 0. Now ask yourself a question that is this 3 the leaf? Because first we need to find out the leaf, right? So we say that hey, 3 is not the leaf, right? Are 5 and 1 the leaf? We are going to check with 3 that are their children the leaf? No, they are not the leaf. So then we are going to ask 5 and 1 that are your children the leaf? And it will get an answer that 6 is a leaf, 0 is a leaf, 8 is a leaf, 2 is not a leaf. And if 2 is not a leaf, it means that this 2 can have a leaf which is at a deeper level because these are the leaves, right? But this is not a leaf. It can have more nodes inside this and they can act as our leaf. So 7 and 4 are going to be our leaf. Yes, they are the leaves. So now let us make note of what are the leaf nodes. 7 and 4, right? 7 is a leaf and 4 is a leaf. What is the parent of 7? It is 2. What is the parent of 4? It is 2. And since both of them have the same parent, this will be our answer. Well, this might seem easy in BFS when the number of leaves are 2. But what if the number of leaves are more? So let's say we have another leaf here, which is 9. Now in this case, 6 and 2 both will say that I have a leaf inside me. And 0 and 8, although they are the leaf nodes, they are not the deepest one. Now the deepest leaves are 9, 7 and 4. So we will have 9 as well. And the parent of 9 is 6. My deepest leaves are 7, 4 and 9. But their parents are not same. So now I will have to ask their parents, what are your parents? So the parent of 2 and the parent of 6, right? So parent of 2 is 5, parent of 6 is 5. And now both have a common parent and 5 is going to be our answer. So now since you need to backtrack from your leaf nodes to get the parent, common parent here or the common ancestor, this can be a bit tricky to implement it using a BFS. So here you will have to maintain a upper parent level of each of the nodes, right? So that whenever you get the leaf nodes, the deepest leaf nodes, you try to backtrack to get the answer. But when you will try to do the same thing using DFS, you will notice that the backtracking part is automatically implemented. Let us see how. First of all, let us get rid of this and let us try to use the DFS method. In the DFS, what we do is we first try to go to the deepest level itself. So first of all, we are going to see the root node, and since the root node has children, it will go to the left, which is 5. And since this 5 is also having a children, it will again go to the left and it is 6. Now 6 doesn't have any children, right? So when 6 doesn't have any children, so then we are going to ask this 6 that 6, can you be an answer? And 6 will say, yes, I can be an answer because I am a leaf node. As of now, I am the deepest because we have not seen these nodes as of now. So we don't know if there are more deepest nodes. So this will say, yes, I am the deepest node as of now. and I can be an answer because this particular node 6 is having all the nodes as of now which are the deepest leaf nodes, and this is part of the family as well, right? So for now we will say that 6 is the answer. Now we are going to return back to 5 automatically, and the 5 has got an answer from its left node that 6 is an answer. Now what is the level of 6? Because we need to find the lowest level answer. So 6 can be an answer, but the level of 6 right now is 2. Okay, so 2 is the level because this is 0, this is 1, and this is second level. So 6 is our current answer, which is at level 2. Now 5 is going to ask its right node that what do you think? Can you be an answer? So 2 will say let me ask my children first. 7 can be an answer, 4 can be an answer again. And 7 is at level number 3 and 4 is at level number 3. Now when 7 and 4 they will come back to 2, then 2 will understand that my left is also an answer, my right is also an answer, and both are at the same level. And because the levels of these nodes are same, 2 itself can be an answer. This is because 7 and 4 are at the same level. It means they are the leaves. If they are the leaves, the common parent is not going to be 7, not going to be 4, but going to be their own parents, which is 2. So we can simply remove it and we can simply say that 2 is an answer. The node 2 is an answer, and the node 2 has the deepest leaves at level 3. Okay. 6 was an answer which has the deepest leaves at level 2. 2 is an answer which has the deepest leaf at level 3. So now again 2 will come back to 5 and 6 is also back to 5. Now 5 will ask the same question which 2 was asking from 7 and 4. 5 will ask their children, can you both serve as an answer? They both will say that yes, I am an answer and I have the deepest node or the deepest leaf at level 2. But 2 will say that I am also an answer and my deepest nodes are at level 3. So 5 will say okay, since 2 is the better here because 2 has the deepest level nodes, then 2 will be my answer. But 5 itself cannot be an answer, and the reason is both of its children are not having the same level. So in this case 5 is going to say that I have an answer, I myself is not an answer, but I have an answer, and the answer according to me or the output according to me is the node 2 which is at level 3, and now the node 5 is going to return back to 3. Now the node 3 has got an answer, got an output from its left hand side. From its left side it got to know that 2 can be an answer which has its leaf nodes at level 3. 5 itself couldn't be an answer because it has children's and its own children's are not having the same level of answer. The answer for 6 was level 2, the answer for 2 was level 3. So since their own levels are not same, we can easily say that only one of them contains the deepest leaf, and the one which will contain the deepest leaf will have the value of level more. Okay, so 2 and 3 is our answer according to 5, and this will pass this information automatically to 3. So 3 will ask right side as well, and 1 will say okay, let me ask my children's. It will ask 0, it will ask 8. Both are the leaf nodes and both can serve as an answer, and both are at level 2. So right now 1 can say that okay, since my own children are at the same level, I can myself be an answer, I can myself be the ancestor or the common ancestor for the leaf nodes. But are these the lowest leaf nodes? No, they are not, because according to 1 which is at level number 1, the answer will be node 1 with level 2, because node 1 is an answer and the deepest leaf it has seen is at level 2. Now it will pass this information to 3, and we have got some information from 5 as well. The information is node number 2 is an answer and node number 1 is an answer, right? Node number 1 is at level 2, node number 2 is at level 3. So now 3 itself cannot be an answer because it found that okay, my left hand side and my right hand side both are having different levels. One is level 3, one is level 2. So I myself cannot be the common parent for all the deepest leaf nodes. But since 2 is an answer or 2 is an output which is having deepest leaf nodes and its level is more, its level is 3. So it is more downwards in the tree, and that is why the final outcome will be 2. And that is the complete explanation of this particular problem. Now even after the explanation, if you are a bit confused, then what I can do is I will code the solution, and after I do the coding part using Python, everything will be crystal clear. So let me go back to the code editor and let me try to code it using Python. So first of all, I will create a helper function, and this is going to find out the answer for each node. Okay, so it will take a node as an input, and if the node itself is null, right? So if not node, then in that case we are going to return two values. We can say the height is 0 and the node itself is none. So this is going to be the base condition for our function. Next we are going to find what is the answer for the left side of the node and the right side of the node. So left is going to be equal to helper. We are going to call helper again with node dot left, and we are going to say right is equal to helper node dot right. Now we need to check few conditions. If the left 0, what this will be? This will be equal to the height of the tree, right? So if the height of the left side is equal to the height of the right side, it means that the current node itself can be the answer or can be the common ancestor. So we are going to return height plus 1. So whatever height we are at plus 1 and the node itself, right? This is going to be an answer in case the left side and right side both are same. But what if the left side value or the left height is more? So if the left of 0 is more than the right of 0, in that condition we are going to return the left side, left of 0 plus 1, that is the height of the left side, because that will contain the deepest leaves, and the answer we are getting from the left hand side. So left of 1, this is going to be the node. Else we will reach to the else if the right hand side or the right part or the right node or the right subtree is having more height or the more levels. So in that case we are going to return the answer from the right hand side or the right subtree. So return right of 0 plus 1 and right of 1. So this is going to be the height and this is going to be the right subtree node, or whatever answer we are getting from the right subtree. And then after we come out of this function, we are going to call this function. Okay, first let me correct the alignment. So let me select this part of the code and hit tab, so it will just correct the alignment. Now we can just call this helper function. We are going to first fetch the height, and we are going to fetch the lowest common ancestor, which will be equal to helper and root. We are going to check from the root, and after the helper function is done with the operations, we can directly return the value of LCA, which is the lowest common ancestor. And now this is the complete code of this particular problem. When you will submit the code, you will find that this will be accepted for all the test cases. Yes, this is accepted for all the test cases, and this is a pretty good solution for this particular problem. So that's it for this video, guys. I hope you got the understanding of this problem and the solution approach as well. And if there are any doubts, I hope that got cleared. But in case you have some more doubts which are still not clear, just make sure that you put it in the comment box and I will answer to your doubts. And if this video helped you, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you hit that subscribe button as well. And I will see you guys in the next video. Thank you for watching this video, guys.